Hello everybody, hope you might be doing well. So yesterday we discussed load transfer mechanism from slab to beam. Today I have chosen one of such topic like determination of different ingredient in 1 meter cube concrete. Means different ingredient means cement, sand and coarse aggregate. when Whenever our engineers get their degree and diploma and they go to the site for the first time, and masons and head mason ask them to the amount of the cement and sand for 1 meter cube of concrete, so they do not have any exact answer, because amount of cement, sand and coarse aggregates does not only depend upon the concrete but depends upon the grade of the concrete also. What type of the grade of concrete you are talking about? Is it M20, M50 or M5? So this is the way most of the YouTuber have been making video to determine the amount of the cement, sand and coarse aggregate in such fashion. Okay, so I explain their method. Dry weight for 1 meter cube concrete is 1.54 time into 1 meter cube. For 1 to 4 concrete is cement is equal to 1.54 into 1 upon 7. 7 is 4 plus 2 plus 1 meter cube, and if we multiply the volume of the cement by the density of cement, we get the weight of the cement, and similarly we get the weight of the sand in same fashion. Is it right? It is absolutely wrong. It is conceptually wrong. So what is the right way? How to calculate the exact amount cement, sand and coarse aggregate? I will explain you one by one. To explain these concepts, let's take an example. Grade of concrete is 1:2:4, means M15. Void ratio in cement 62% of its volume. Void ratio in sand 41% of its volume. And void ratio in stone is 45% of its volume. Now you people might be thinking, how can be the void ratio 62% of its volume, even 41% of its volume? To explain you this concept, 1 meter cube concrete and different ingredients, I took an example from UPSC Engineering Services examination. So I didn't take any data from my own side. These are the data given. But in actual practice, the void ratio is very less. I think the void ratio in concrete vary 5 to 10%. Okay, because as the void ratio increases, strength of concrete decreases. But this is an example. So I took a standard example. So in practical life, this percent is very less. Anyway, to clear the concept, just take these value and we calculate the amount of cement, sand and coarse aggregate conceptually. Okay. Before going further, we must know the different parameters of cement, sand and stone. For example, density of cement 1440 kg per meter cube and sand 1700 kg per meter cube and stone 1600 kg per meter cube, and void ratio and M15 grade concrete generally varies between 0.55 to 0.6. So let's proceed. Let's assume weight of concrete in 1 meter cube of concrete is equal to X. So since the ratio is 1:2:4, then weight of sand in 1 meter cube concrete would be 2x kg. Why? Because this ratio is always by weight, not by volume. Most of the peoples are committing this mistake. They are calculating the amount of cement, sand and coarse aggregate, not they are calculating the volume of cement, sand, coarse aggregate by this formula 1:4. But this is by weight, not by volume. You can calculate this the amount, the volume, the weight by this method only, not volume. Okay. Anyway, let's assume weight of cement in 1 meter cube x kg, 2x kg, and weight of stone would be 1:4, 4x kg. Okay, now you might know volume of concrete will be equal to volume of void plus volume of solid plus volume of water. It is very clear. You people might know it. Now we shall calculate volume of voids, solid and water one by one. Then we will put these values into this equation. So let's suppose this is equation 1. Okay. Now volume of void. What will be the volume of void? As we are given, for cement 62% of its volume. Okay, so weight of the cement is x kg. If we divide weight by density of cement, we get the volume of cement. So x upon 1440 is nothing but the volume of cement. So volume of void is equal to 62% of its volume. 62 by 100, it becomes 0.62. But within the sand, 40% of its volume, void ratio in sand is 41% of its volume. So we are calculating the total volume of voids, 62% of, it is 62% of cement and 41% of sand. It means 2x upon density of sand 1700 multiplied by its 41%, 0.41 plus this stones 44x, since ratio is 1:4, upon density of stone 1600 kg per meter cube and percentage is 45%, 0.45. This is equation 2. Okay, so we have to calculate the volume of concrete, and so far we have calculated volume of voids in such a fashion: 62% for cement, 41% for sand and 45% of stones. Now we proceed to volume of solids. So what will be the volume of solid? You can note it down. Okay. Now volume of solid is nothing but x upon 1440 plus 2x upon 1600 plus 4x upon 1700 kg per meter. This is simple. We are dividing weight by its density and we are getting the volume. Weight upon density, mass upon density is equal to volume. So this is, let's suppose this is equation 3. Okay, so far we have calculated volume of voids and volume of solids. Now we calculate volume of water. what will be the volume of water? Volume of water would be, because water cement is 0.55, then weight of water will be the weight of cement multiplied by 0.55. Then 0.55 weight of cement is x kg. This x kg we have considered. So this is weight of water. If we divide weight of water by the density of water, 1000 kg per meter cube, we will get volume of water. So this becomes equation number 4. Okay. Now we can put the values of different volume in this equation. We shall get the value of x. So equation 1, this is volume of concrete is 1 meter cube. Volume of voids we have calculated in equation number 2, this value. So we shall put this value here. After that, volume of solid we have calculated by the equation number 3, volume of solid. And last term is volume of water. We have calculated the volume of water. Now we shall put these 3 values 1, 2 and 3 in this equation. So it becomes, if we add this and this, it is nothing but x upon 1440 and 0.62 and 1. It becomes 1.62 plus 2x upon 1700 and 1 or 0.41. 1.41 plus 4x upon 1600, 4x upon 1600, 1.4. 4x upon 1600, 1 multiplied by 1.45. I just erase this portions. So this is volume of water, volume of voids plus volume of solid plus volume of water. What is the volume of water? 0.55x upon 1000. Okay. So this is the complete equation. This is volume of concrete is equal to this volume of that volume. If we solve this equation easily, we get, I have noted down its value, 143.7 kg. X comes to be 143.7 kg. What was the x? X was the weight of cement which we have considered at starting, at beginning. Okay. If we have calculated value of x, then it is nothing but weight of cement. Then we can easily calculate weight of sand. That is 2x. We can multiply 2 times 143.7. And similarly, because the ratio is 1, 2 and 4, then weight of stone is equal to 4 times x. That is 4, and value of x, that is the weight of cement, 143.7 kg. So these will be the value of weight of cement, sand and stone for 1 meter cube concrete. This is conceptually right. If you want to calculate the values in 1 meter cube concrete, so this will be the way. Okay. There is a question, void ratio may be differ. Okay. In this question, void ratio has been given comparatively higher. So in practice, void ratio is comparatively less. but this is the conceptual way, because 1 to 4 is by weight, not by volume. Just remember this. Okay. So I think you might have got it very properly, very conceptually. If you feel any doubt, you can ask me freely. You can ask me on the comment sections. I think I have done it completely. Okay. So if you like the video, please share, subscribe my channel, and I will keep on making such video which are conceptually not understood. Okay. Because if a YouTuber makes some video, other YouTubers copies him or her. Okay. So we should not trust blindly. We should investigate the things, whatever the mistakes they have made. But anyway, this is the way. One more thing is there. If you calculate the value of cement, sand and coarse aggregate by volume, it may be the value obtained by this method and that method may be little closer to each other, but that is conceptually wrong. For example, amount of cement sand aggregate differ by 5%, and if you are creating 1000 meter cube concrete, so there may be a larger difference. Okay, so that is not conceptually right. So I think you like the video. Thank you very much.